With everyone, here's our math challenge for today. And here's our question. Solve for the real value of x given that x squared plus 2x minus 1 quantity squared plus 2x squared plus 3x equals 3. Now, you can pause this video if you want to give this problem a try. Now, let's answer this question together. Our goal in this question is to solve for the real value of x. There's a lot of ways to answer this kind of question, but here's one of them. So what we're going to do is to focus on this expression x squared plus 2x minus 1. If we can replace this expression with a single variable, then our equation becomes more simple. Now let's do that. First thing is to take note that 2 times the quantity x squared plus 2x minus 1 is equivalent to 2x squared plus 4x minus 2. Now take note that we have here 2x squared, so we don't have problem on the first term. But we only have 3x, but we want 4x. So what we're going to do is to add x on both sides. The reason is 3x plus x is just 4x. So to have 4x. Now, we also need minus 2 or negative 2. So let's subtract 2 on both sides. Now, we complete our expression 2x squared plus 4x minus 2. But let's simplify first the right-hand side. 3 minus 2 is just positive 1. Now, we can replace this expression 2x squared plus 4x minus 2 with 2 times the quantity x squared plus 2x minus 1. And now, since we have the same expression, so we can replace this expression with one variable and let's call this as p. So, all of this expression can be replaced now with the variable p. And now our equation becomes p squared plus 2p equals 1 plus x. Now, notice that p squared plus 2p is somewhat related to perfect square trinomial if we have 1 on this term. So let's add 1 on both sides. So we have p squared plus 2p plus 1. And this is now factorable and is equivalent to p plus 1 quantity squared. Now on the right hand side, we have 1 plus 1 or simply 2. Now, since p, we let p as x squared plus 2x minus 1, so we can bring back the value of p. Now take note that we can cancel out negative 1 and positive 1. Therefore, the expression on the left-hand side is equivalent to x squared plus 2x quantity squared. Now, if we factor out x on this expression, this is just x multiplied by x plus 2. Why we do that? Because take note that we have also a factor of x plus 2 on the right-hand side. But x times x plus 2 quantity squared can be written as x squared times x plus 2 quantity squared. And now, let's subtract x minus 2 on both sides. And then, let's factor out this common factor x plus 2. This will give us x plus 2 times the quantity x squared times x plus 2 minus 1. Now, let's distribute this x squared. This will give us x cubed plus 2x squared. And since our goal is to solve for the value of x, so what we're going to do is to try to factor this cubic expression x cubed plus 2x squared minus 1. Now, how are we going to factor this cubic? This 2x squared can be break down into x squared plus x squared. And now, I can see something beautiful because if we factor out x squared on the first two terms, we have x squared times the quantity x plus 1. And x squared minus 1 is difference of 2 squared. So this can be factored as x minus 1 times x plus 1. And again, we have a common factor of x plus 1. So we can factor out x plus 1. This will give us x plus 1 times the quantity x squared plus x minus 1 equals to 0. Now, since it is in factored form, and it is equal to 0, so we can say that at least one of them must be equal to 0. So we have now x plus 2 equal to 0, x plus 1 equals to 0, and x squared plus x minus 1 equals to 0. Now let's solve for the value of x. On the first equation, x plus 2 equal to 0, if we subtract 2 on both sides, we get that x must be equal to negative 2. On the second equation, if we subtract 1 on both sides, we get the value of x must be negative 1. And on the third equation, this is a well-known equation, and if we get the value of x using quadratic formula, we get the golden ratio. And golden ratio is equivalent to 1 plus or minus square root of 5 over 2. Therefore, the values of x in this equation must be equal to negative 2, negative 1, or the golden ratio, 1 plus or minus square root of 5 over 2. And as always, we are done.